Okay, good morning. So this video will be I will be talking about profile leveling. So by the end of this discussion, with this lesson, we're expected to know these three learning outcomes. First is we'll be able to discuss what is leveling, then explain why do we need to conduct leveling, and to know how to compute profile leveling data and produce profile. First, we will define profile leveling. So, by the name itself, profile, so atupaon ang profile sa ating terrain. So, by definition, profile leveling is a process of determining differences in elevation along a fixed line at the designated short measured intervals. So, recap no, sa atong previous lesson, the previous discussion, we define or discuss about differential leveling. So, sa differential leveling, process siya to measuring differences in elevation between two or more points. So, in differential leveling, assuming this is point A or in benchmark 1, and this is point B or in benchmark 2, so ang process to determine the difference in elevation between two points is called differential leveling. So, in differential leveling, wala na to i-consider ang forma sa ating terrain. Ang ato na ang difference in elevation between two points. But, in profile leveling, ato siya ang take into account ang forma sa ato terrain. So, we will measure the difference in elevation or atong kuanan at what point taas ang elevation sa ato i-survey or sa ato terrain or at what point ubos ang iyaha elevation. Ato i-take into account ang iyahang terrain or the ground surface. So, this one, assuming top view at top view. So, this is our setup sa ato instrument, this one. So, sa atong leveling, we take backside sa ato reference or sa ato benchmark 1 or atong known elevation. Then, we take the foresight sa ato turning point. But in profile leveling, we take set of shots or measurements at short intervals. This one. So, we take o mga sites ana or readings para makuha nato ang forma sa ato terrain. Dili lang ang atong backside sa atong known elevation and sa atong turning points, but also sa mga short measured intervals, atong kuan o shots or readings. Then, a profile is necessary for the design and construction sa atong roads, railroads, sa canals, culverts, bridges, and sewer lines. So first, we will define mga terms na we need to know to better understand profile leveling. Profile is a curved line which graphically portrays the intersection of vertical plane with the surface of the earth. So this one, mani ang atong profile sa atong terrain from station 0 plus 0, 0 to 7 plus 0. Stationing or a numerical designation given in terms of horizontal distance. Any point along a profile line is away from the starting point. So notice sa atong graph, ang atong x-axis is naka-name siya as stationing. For 0 plus 0, it means 0 meters siya or ang atong siyang starting point. Then 1 plus 0, it means 100 meters from the starting point. 2 plus 0, 200 meters from the starting point. Or kung 300 meters, pwede na ito siya isuwat as 3 plus 0, and so on and so forth. So, sa ngari, kung natin na 0 plus 20, so it means 20 meters siya away from the starting point. Then 0 plus 40, it means 40 meters away from the starting point. So, kaning 0 plus 60, it means from the starting point to this point, 60 meters via horizontal distance or distance along the curve. Intermediate foresight are also called as ground duties. These are taken along the center line of the proposed project to provide an accurate representation of the ground surface. So, ang atong mga take shots na po at regular intervals mo na ang intermediate foresights or IFS. So, in this case, atong mga intermediate foresight is 0, station 0 plus 20, 0 plus 40, 0.6 plus 60, and 0.80. Sa second setup naman po, ang atong mga intermediate foresight is 1 plus 20 or 120 meters from the starting point, 1 plus 40, 1 plus 60, and 1 plus 80. Next is full station are points which are established along the profile line level route at uniformly measured distances. So, in this case, ang atong mga full station is 1 plus 0, 0, and 1 plus 2, 0, 0. Usually, ang full stations ay multiples na siya sa 100, 150, or 30. That is a 20 or 10 meters. Plus stations. Kung siya any other intermediate point established along the profile level route. So, ang plus stations, any site siya at na other than intermediate foresight. Usually, paano natong mga sites ang mga sample. This one. These points are taken at breaks in the ground surface slopes and at critical points such as intended location of culverts, bridges, and other structures. For example, kinahanglan natin siya i-measure ka nga rin o take the readings na rin or mo station ka nga rin kay naatay butang nga culvert. So, dapat mahibaon siya sa elevation niya rin. So, kana siya, gitawag na nato o plus site. So, any site aside from intermediate point. Next is vertical exaggeration. It is a process of drawing the vertical scale or profile much larger than horizontal scale in order to accentuate the differences in elevation. So, sa atong pag-plot nito sa atong profile, so, ato lang siya i-exaggerate ang elevation to para mas ma-visualize nato ang changes in elevation sa atong profile. So, it is called vertical exaggeration. Ang process under vertical exaggeration. Next is profile leveling. A special heavy-grade graphing paper used for plotting profiles. So, ang pag-plot na paano natin special paper na ato gitawag na profile paper. So, sa atong profile level notes, ano siya? For nanatry 6 columns. Diba sa differential level notes, ang stations lang, backside, height of instrument, or elevation of our line of sight with respect sa datum or with respect to the mean sea level. Next is the foresight. Then, ang kanini, muna itong additional columns sa profile level notes, the intermediate foresight and the elevations. Let's now proceed to the sample problem. Compute the following set of profile leveling notes and show the customary arithmetic check. So this is your given different profile level notes. We need to compute the HI as well as the elevation of the stations. So remember, we have these two formulas. Height of instrument is equals to elevation of the station plus backside reading. And the second formula is elevation of the station is equals to HI or height of the instrument minus foresight reading. So first, we'll compute the height of instrument at first setup. So elevation of benchmark 1 is formula plus backside reading, which is 0.95 meters. That will give us height of the instrument or the elevation of our line of sight equals to 126.45. So just fill out 126 here. Next, for the second, to compute the elevation of station 0 plus 0, 0, the elevation of 0 plus 0, 0 is equals to height of instrument, which is 126.45 minus intermediate foresight reading. That is 3 meters. So, 126.45 minus 3, that is 123.45 meters above mean sea level. That would be our elevation at station 0 plus 0, 0. Okay. Then, this formula again to solve the elevations of other intermediate of other stations. So, for the elevation of station 0 plus 30 meters, or 0 plus 30, HI 126.45 minus 2.55 equals 123.95 meters. And the same formula to be used to solve this elevation of 0 plus 70, station 0 plus 70, 126.45 minus 2.25 meters. That will give us 124.20 meters. Then, to solve the elevation of turning point 1, height of instrument minus foresight reading. So, 126.45 minus 2.48. That will give us an elevation equals to 123.97 meters. Okay. Then same formula that will be used for the other station to solve the elevation of other station as well as the height of instrument for the second setup. So kindly get your calculator. Okay, let's solve the height of instrument for the second setup. So 123.97 minus backside reading, which is 1.55, equals 125.52. Then, for the elevation of station 1 plus 0, 0, 125.52 minus 2.17. That is 123.35. Then, elevation of 1 plus 40, 125.52 minus 1.98. That is 123.45. And for station 1 plus 70, 125.55 height of instrument minus foresight reading, intermediate foresight reading, that is 123.78. And to solve the elevation of benchmark 2, height of instrument at turning point 1, height of instrument for the second setup minus foresight reading, which is 1.59, and our elevation for benchmark 2 is 123.95. This is our complete profile level notes. The next is to show the customary arithmetic checks. So to compute arithmetic check, we need to use this formula. Elevation of the known benchmark plus summation of this column, which is summation of the backside, minus summation of the foresight readings, equals to our computed benchmark, which is benchmark 2, which is 123.93. So summation of this backside 0.95 plus 1.55, that will give us 2.50. And for the summation of the four side 3 beams, 2.48 plus 1.59, that will give us 4.07. The elevation of benchmark 2 is equals to 123.93, which is equals to our computed elevation of benchmark 2 a while ago. So this arithmetic check again will just give us the idea that our computed HI as well as the elevations are correct. Okay, next sample problem. A turning point along a profile level route measures 126.44 meters beyond station 08 plus 24.50. So we're asked to determine, first is the station of the turning point, next is to determine the stationing of the turning point if it is instead located 83.45 meters below the given reference point, and lastly, to determine the distance between station 33 plus 45.02 and station 26 plus 62.75. So, first problem is determine the station of the turning point. So, we have this station which is 80 station of 8 plus 45, 24.50. Next is our turning point located beyond sa station 8 plus 24.50. So, nga rin siya ang ating turning point. Distance from station to turning point is 126.45. Okay, we have 126.45. Again, this station or distance of the station is equals 8 plus 24.50, or it could be written as 824.50 meters. So from starting point to this station, it has this horizontal distance of 824.50 meters. Next is distance of the turning point from this station is 126.44, which is given na siya na. So, to solve or to determine the station of this turning point, we will just add the distance of the station plus distance of the turning point, which is 824.50 plus 126.44 meters. And that will give us an answer of 950.94. And since station man ang gipangayo, so this 950.94 can also be written as 9 plus 50.94. Then no need to write the units. Okay, so mo niya the answer for letter A. Next is B. So again, the problem for example 2B, determine the station of the turning point if it is instead located 83.45 meters before the given reference point. So, before na po siya, ganina kay diyan, after na sa at the station. So, study kay before man, so we have a station, so the station na to 8.24.50, nga kay before man ang atong turning point, so nga rin atong turning point, before. So, distance from this station to the turning point is 83.45 meters. So, para makuha ang atong turning point, so, distance sa ato station is 8 plus 24.50 or equals to 840, 24.50. 824.50 meters. Then, distance from this station to turning point is 83.45. Since kay before man siya, ato na siya i-minus. 824.50 minus 83.45, that is 741.05 meters. And again, kay station may gipangayo, ang station, so station at the turning point is equals to 7 plus 41.05. Okay. And lastly, we need to determine the distance between two stations. Station 33 plus 45.02 and station 26 plus 62.75. So, natin ka station na. Then, ang atong isa ka station kay 26 plus 62.75. And for ang isa ka station kay 33 plus 45.02. So, ang atong kinahanglan i-determine is the distance between these two stations. So, for station 1, it could also be written as 2,662.75 meters. And for station 2, this equals to 3,345.02 meters. So, to determine ang ilahang ilahang distance between these two stations, ato siya i-subtract. So, station 2, distance of station 2 minus distance sa station 1. And that is 682.27 meters. So, ang distance ani nila duha between these two stations is equals to 682.27 meters. Okay, and I think that would be all for profile leveling.